Hello everyone, welcome back to the third lecture on the friction. Okay, in previous lecture, we discussed about the different laws of the frictions, different terminologies which are related to the friction. Okay, like angle of repose, limiting value of the friction, etc. Today we'll move ahead and we'll cover friction in the journal bearing and the power transmission in the journal bearing. Okay, so let us get started with the lecture. So this is the content in the today's class. We'll be dealing with the friction in the journal bearing and we'll calculate the power transmission in the journal bearing. Okay, so let us try to understand and let us try to find out what will be the expression to find out the power transmitted in the journal bearing. Okay, so this is the figure which is given. Okay, the outer fixed part, this outer fixed part is called as the bearing. The outer fixed part is called as the bearing. The inside part, the circular part, is called as the journal or a shaft. Okay, so the journal which is there, which will rotate inside the bearing, the journal which is rotates inside the bearing. Okay, the pair between the journal, that is the shaft, and the bearing, okay, it forms a turning pair at a point A. Okay, so next thing is the diameter of the journal is the less than that of the bearing, which allows it to rotate freely inside the bearing. Okay, so next is we'll discuss different parts like W. The W is nothing but the a load which is acting on the journal. Rn, Rn is the reaction force to the journal. Okay, O is the center point of the journal. Okay, so what are the different terminologies which comes when we go for the finding out the power transmission? Okay, first one is phi, which is given, which is nothing but the angle between R and the Rn. Okay, angle between R and Rn. So where it is phi, so here you will find out the phi, which is the angle between the R and the Rn. So Rn is nothing but the normal reaction and R is nothing but the resultant force. Next, mu. Mu is nothing but the coefficient of the friction. So how we find out the coefficient of friction? It is nothing but the ratio of frictional force to the normal reaction, that is Rn. Okay. Next, T. What is T? T is nothing but the frictional torque, which is measured in terms of Newton meter, and the R is nothing but the radius of the journal or shaft in the meter. Okay. Next, so how we find out the torque transmitted? Torque is nothing but it is given by W, which is load, into the radial distance or radius, that is R. Okay, we will multiply this to the mu, which is nothing but the coefficient of the friction. Fine. So mu into W into R is represent the torque transmitted. Okay, if we want to find out the power, what we have to do is we have to simply multiply torque with the W. So W here is nothing but the angular velocity. Okay, so if we expand it further, it is nothing but you will get W is nothing but 2 pi n divided by 60. 2 pi n divided by 60, and the power is measured in terms of watt. Okay, and R is and N is nothing but the speed with which the journal or shaft is rotating about the axis inside the bearing. Okay, so this is what the a formula to be used when you go for the calculation of the power transmitted in case of the journal bearing. Okay, I hope it is clear. Thank you.